are going to do some questions which will help you in doing graded assignment 2. So we have our first concept. What is frequency distribution? What is frequency distribution? A frequency distribution of qualitative data is listing of the distinct values and their frequency, right? So for example, I raised a coin and I have different observation here. Okay, so what do you mean by the frequency? The number of times an object has occurred, right? The head has occurred for 3 times. Similarly, for tail it has occurred for 3 times. So this is known as the frequency. It is the listing of the distinct values and their frequency. Okay, now what is relative frequency? The ratio frequency to the total number of observation is called relative frequency. Okay, by the mathematical equation we can say relative frequency is equals to the frequency divided by the total number of frequency of that observation. Okay, now we have our question 1. Consider the following frequency table to see how many students in a class have got marks between the given intervals in statistics. So we have been given different intervals of marks. We have the frequency and we have the relative frequency. So our first question is, find the total number of students in the class. Okay, we have to calculate the total number of students. We have to calculate the total number of frequency. Okay, so how we will calculate? We have been given the number of students between 55 to 60 is 10, right? From the table we can see it's 10, and from 65 to 70 it is 11, right? Now relative frequency for mark 50 to 60 is 0.2, correct? Now we know that relative frequency is frequency upon total frequency. So if we cross multiply it, we can get total frequency is equals to frequency upon relative frequency. Now for marks 55 to 60, okay, we have been given relative frequency as well and we know the frequency also. So we can calculate the total frequency, which will be 10, which is the frequency of that object of that marks, and we have the relative frequency here. So by equation we can get 50. So the total number of students in the class is 50. Okay, now next we have other question. It is, we have been given the same table only, but we have some changes in it. It is noticed that the number of students for marks in the interval 60 to 65 is 1 less than the number of students in the interval 50 to 55. Okay, now we have the question is, find the number of students who got marks in between 50 to 55. Here we have been given a condition that the number of students for the interval 60 to 65 is 1 less than the number of students for interval 50 to 55. Okay, now we have considered, let the number of students in the marks with the marks in the interval for 50 to 55 be x. So we have been given the interval for 50 to 55 is x, number of students. For 60 to 65 it will be x minus 1. Why? Because the number of students for 60 to 65 is 1 less than the number of students for 50 to 55 minus 1, right? So if we have conditions, we have been given that the number of students for 50 to 55 is x, then for 60 to 65 the number of students will be x minus 1 only, right? Now since the total number of students is 50, so we can calculate x, which is the number of students for which number, for 50 to 55, right? Then we have 10 for 55 to 60. This is for 60 to 65, right? 65 to 70. Okay, this is 55 to 60, 50 to 55. Okay, the total is 50. So x plus x, we can open the bracket. Okay, here we have 2x. Then by calculating this we get 20 equals to 50. then 50, we will put this 20 here, signs will get changed, then 2x will be equals to 30, so x will be 30. If 2 gets here, it will be in divide, which is 15, so our value is x equals to 15. So the number of students who got marks between 50 to 55 is 15. Okay, now we have the same situation, but we have to count the number of students who got marks between 60 to 65. We have to calculate this one. Okay, we know from the above question the number of students for 60 to 65 is what? X minus 1, and we have the value of x, which is 15 minus 1, which is equals to 14. So here we have the solution. Let the number of students with the marks in the interval for 50 to 55 be x. We have for 60 to 65 is x minus 1. So putting this in this equation, we can get x plus 10 plus x minus 1 plus 11 equals to 50. Solving this equation, we get x equals to 15. So the number of students who got marks between 50 to 55 is 15. So the number of students who got marks between 60 to 65 is x minus 1, which is 15 minus 1, which is 14. Okay, now we have next question. We have to calculate the relative frequency of the marks in the interval 60 to 65. Okay, we have to calculate this value. So here we have been given the value of 60 to 65, okay, which is 14 only, and we know the total frequency as well, 50. So by the formula that was studied earlier, which is frequency divided by total frequency, we have the frequency, we have the total frequency, which is 14 by 50. Okay, by this we can get the relative frequency, right, which is 0.28. Now we have question 2. We have been given two tables, okay, frequency table for data set 1 and frequency table for data set 2. We have to find the relative frequency for categories listed in data set 1 and data set 2. What is the formula of relative frequency? Frequency divided by the total frequency, right? First we will calculate the total frequency, which is 4 plus 1 plus 5, which is 10. Similarly for this as well, we have 40 plus 10, 50, 50 plus 50, 100. Now we can calculate the relative frequency, which is frequency divided by the total frequency, that is 0.4. Similarly 1 divided by 10, which is 0.1. Similarly 5 divided by 10, which is 0.5. Now same here, 40 divided by 100, 0.4, 10 divided by 100, 0.1, 50 divided by 100, 0.5. So here we have the answers. So the relative frequency for both data 1 and data 2 are same, even though the frequency distribution for both the data sets are different. Yes, we have the frequency distribution for data set 1 is 4, 1 and 5, right? Here we have different frequencies, and here we have different frequency. One is 4, 1 and 5, one is 40, 10 and 15. We have different frequency distribution, right? But we have the same relative frequency. Okay, next question. Here we have data set A, B, data set 1, and we have data set 2. Will the relative frequency be the same for data set 1 and data set 2? So for this, we can calculate the frequency here, right? So we have calculated relative frequency here by the formula that we have studied earlier, right? So here we can see the total. So we can calculate the total, which is 10, right? And here we can also see the total is 20, right? So 2 divided by 10, it is 0.2. 5 divided by 10 is 0.5. 3 divided by 10, it is 0.3. Similarly, 4 divided by 20 is 0.2. 10 divided by 20 is 0.5. And 6 divided by 20 is 0.3. So here we can see that the relative frequency for both the data set are the same, corresponding to the frequencies of the categories in the data set, but the frequency distribution are not the same, right? So here we can see we have got same relative frequency, but we have different frequency distribution. Okay, so according to the statement, we can see the relative frequency for both the data set are same, okay, but the frequency distribution are not the same. Now we have the concept of bar chart. What is a bar chart? It is the graphical representation of frequency distribution of a categorical variable. Each bar represents a category. The height of the bar represents the frequency or the relative frequency of that category. Okay, so here we have that I have drawn as a bar graph. Okay, so here we can see that the height or the length of the bar represent the frequency of that observation. Okay, so height of the bar represent the frequency, or we can say the relative frequency of that category. Okay, so this is known as the bar graph, and it should be positioned so that they do not touch each other. They should have some gap in between. Okay, and the width or the area of all the bars should be same. Now, what is the Pareto chart? It is same as the bar chart, except that the bins are arranged in either descending order or in ascending order of the frequency. So here before that I have drawn here was a bar graph. But if we have the bars in order, like in descending order or in ascending order, then we say that the chart is Pareto chart. Okay, like this. Now, what is a pie chart? It is a circle divided into pieces proportional to the relative frequency of the qualitative data. Okay, so this is a pie chart. Here, the circles are divided into pieces according to the relative frequency of the qualitative data. The angle occupied by particular categories are into 360. Okay, this is R into 360 degree, where R is the relative frequency of that category. Okay, now it is best to use the pie chart if we are representing relative frequency. If you are representing relative frequency, then pie chart is the best chart. Also, when we want to show the share of a particular category, pie chart is most appropriate graphical technique. Then, if ranking should be in order of frequencies, then Pareto chart is best preferred. Yes, because what is Pareto chart? It is a bar chart, but the bins are in order, whether it's either in ascending order or in descending order. Then, if frequencies of categories are required to be plotted, then we have the bar chart. Okay, if we have to plot the frequencies of the categories. If we have to show the share of a particular category, then we use the pie chart. And if we want the ranking or the chart should be in order, then we use the Pareto chart. Now, question 3. Choose the correct statement from the following. Two data sets having the same frequency distribution will always have the same relative frequency. Yes, it is correct that if we are having same, what is the formula of relative frequency? It is frequency divided by the total frequency, correct? So if we have the same frequency, that means we will be having same total frequency, then we will be getting same relative frequency as well. So yes, it is true that we will always have the same relative frequency. Okay, this statement is correct. Two data sets having the same frequency distribution cannot have the same relative frequency. This is wrong. Like in the above statement, we proved that it will always have the same relative frequency. So this statement is wrong. Two data sets having the same relative frequency will always have the same frequency distribution. It is not necessary that they will have the same frequency distribution, because if we have like two data sets having different frequency distributions but we have the same relative frequency, okay, there are some situations like that. So it is not necessary that we will always have the same frequency distribution. So option 1 is the correct statement. Okay, Now we have question 4th. If Rohan wants to show the results of a class president election in school, then for this purpose, which graph will be most appropriate? Of course, we have to show the frequency of that category, or we have to show the frequency of the number of votes for the president election, right? So we will be choosing bar graph. Okay, and we have the solution here. Bar chart will be most appropriate because for showing the result for the class president election, each candidate would have his or own bar on the x-axis, okay, and the values on the y-axis would be the number of votes the candidate received, and we can also infer who got the maximum vote with the highest bar. So according to the statement, we can draw a bar graph like this. So here we have the x-axis would be the number of each candidate who applied for the election, and these y-axis can be represented as the number of votes who got for to each candidate. Okay, now next question. If Manohar wants to show the percentage of expenditure of his family on different articles like food, education, entertainment, and clothing, so which chart we would be appropriate? It would be pie chart. As in earlier statement, we seen that to show the share of a proportion of any category, we will choose the pie chart. So here is the solution. Pie chart will be the most appropriate for showing the percentage of expenditure. Okay. Now, next question. The sales of different colors of 80 pens in a shop is given in the following pie chart. We have different colors, right? How many blue pens are sold in the shop? In total, we have how many pens? We have 80 pens. And blue pens are, what is the relative frequency of blue pen? Which is 12.5. And by the formula, we can calculate the frequency, which will be the relative frequency into total frequency, which will be 80 into 12.5%, which will be 80 into 125 by 12.5 by 100, which will be 10. Okay, so the number of blue pens which are sold in the shop is 10. So here we have the solution. Out of the total sales of pen, 12.5 blue pens and 25% green pens have been sold in the shop. So total number of pens sold is 80. We have the relative frequency for blue pen is 12.5, and we have the frequency 0.125 into 80, which is 10. So the number of blue pens will be 10. Now we have to calculate the number of green pens sold in the shop. So what is the relative frequency of green pen, which is 25%, and we have the total frequency, which is 80. So the frequency of green pens will be 80 into 25%. Okay, then 80 into 25 by 100, which will be equal to 20. Okay, so there are 20 number of green pens sold in the shop. So here we have the solution. We have 25% green pens. Okay, so the frequency will be 0.25 into 80, which will be 20. Now we have different concepts. What is mode? Mode is defined as the category of categorical variable which has the highest frequency, right? It is defined for both ordinal and nominal scale of measurements. If two or more categories tie for the highest frequency, the data are said to be bimodal. That means it has two models or multi-modal. Okay. Then we have median. It is defined as the middle value in the ordered data. So the process for finding the median is we have to first order the data in ascending or descending order. Then we have to find out the middle value. Okay. If the data has odd number of observations, then we calculate by n plus 1 by 2th observation is the middle value. If the data has an even number of observation, then we take the average of n by 2th and n by 2th plus 1th observation. We calculate their average, and the average is the median. Okay, median is not defined for the categorical variable with nominal scale of measurement as they don't have any order. Median can only be calculated for ordinal scale data because it can be ordered. Okay, now we have question 6. The responses given by Suman on several tosses of a coin is given below. We have different tosses. So first we're going to calculate the frequency for tail, which is 1 2 3 4 5 6 7. We have 7 tails. 1 2 3 4 5 6 7 8. We have 8 heads. So first question is identify the mode. What is mode? As in previous we have discussed, which is the highest frequency, right? So we can see here head has the highest frequency, so mode of the response will be head. Okay, so there are total 15 tosses for which Suman has given responses. There are 7 tails and 8 heads. Since frequency of head is more than tail, so mode of the response will be head. So option B is correct. Now, what can be said about the median of the response? We have been given a data which gives us tail and head, and these cannot be ordered. It cannot be ordered, so we don't have median. Okay, we cannot find out the median because we can only find out median for ordinal data. Okay, so median is not defined for the given data set. So option 4 is correct. So we have the reason the responses here have nominal scale of measurements. Therefore, it is not possible to arrange the responses in either ascending or descending order. So the median is not defined for the responses. Okay. Now we have different concepts. First, we have what is the area principle? A display of data must obey a fundamental rule called the area principle. The area principle says that the area occupied by a part of the graph should correspond to the amount of data it represents. Suppose we have a data like we have a data with frequencies 10, 15 and 5. So the bar should be corresponding to that value. This should represent 15, this should represent 10 and this should represent 5. It should be corresponding to the frequency value. We cannot have bars like this. This represent 15, this represent 10 and we have this represent 5. Right? Here we can see that 15 is greater than 10 and 5, so this bar should be greater than both of them, but it is not. So this is not a correct graph. This is the correct graph. Like here we can see the 15th value have the highest frequency and it has the highest length of the bar. Then we have 10th and then we have 5. So this is the correct bar. Okay, now what are misleading graph? Graphs that do not follow area principle is called misleading graph. What is missing baseline? It is a baseline which does not start at 0, which is also known as truncated graph. That means the starting point should be with 0. Okay. Now, what is the round of errors? When a table entries are percentage or proportion, the total may sum to a value slightly different from 100% or 1. If percentage do not sum up to 100, then pie chart is said to have round off errors and thereby does not follow area principle. Okay, if we have like 33.3%, 33.4% and 33.3%. We have the frequency here, we have the relative frequency here, and now we are going to make a pie chart here. Okay, this represent 33.4%, this represent 33.3% and this represent 33.3%. Okay, now if for the easy calculation we round off these value, which is 33%, 33% and 33%. So as we can see here, if we calculate, if we sum these values, we get 99%, which is not equal to 100%. So a condition is that the percentage should add up to and it should be 100% or 1. So if percentage do not sum up to 100, then the pie chart is said to have round off errors. Thank you.